Swayam Prabha. Digital India. Educated India.
Good morning, good afternoon, good evening my dear friends. This is the 24th lecture for the project management course, and as you know by this time my name, I am Raghunandan Sengupta from the IME department, IIT Kanpur, India. So, in the 23rd lecture we wrapped up the concept of considering the criticality index. So, this was basically the concept where if you keep simulating a job, considering that you want to find out what are the set of activities which makes the critical path. So, the number of times a particular job comes up in those simulation divided by the total number of simulations which you have done, or total number of such instances of experiment you may have done. So, that ratio is basically the critical index, and if you remember I did mention that you will rank them from the highest to the lowest, take the source sets of activities or jobs which have got the highest criticality index, but remembering the fact that they make a sequence of events which add up and basically start from the source which is job number 1 or the node 1 and end on to the last job which is the nth one or the sink, such that you are able to complete and have a feel that how the work progresses. Now, also if you remember I did mention that due date is also important to consider, that how we will consider the concept of due date along with the expected time for the set of all the activities which makes the critical path, and how the variance can also be considered in order to find out that what is the percentage of completion of any particular job, considering T which is the expected time and D which is the due date are coming into the picture. And I also mentioned in the last class and also beforehand that central limit theorem would be used irrespective of the fact that whatever the distribution for PERT were considered. So, we will basically have the graph considering the central limit theorem to be true is this normal distribution, where the central line if you see it is T. So, T is this T if you remember is the summation of all the average time for the critical path, and these standard deviations are basically the variances addition for all the paths, and then you find out the square root, and then if you go 1 sigma to the right, 1 sigma to the left, if you see my this pointer is hovering about on the right hand side, this is 1 sigma, onto the left is the 1 sigma onto the left. So, now see the red vertical line which is there, which is the due date. Now, if you see it will give a feel the due date can also be here. So, the due date can be also here, but whatever concept I am going to mention just now would be true for both the fact whether the due date D vertical line is onto the right or the left, what they would have different conceptual consequence that how you analyze the problem. Now, the due date can also be onto the right of T plus 1 standard deviation, it can also be onto the left of T minus 1 standard deviation. So, this on this idea of where the due date is does not matter if you are able to analyze the problem in its true perspective from the practical sense. So, this is what I will now discuss very briefly in the 289th slide. So, now it sends the chance of completion of a project within the due date. So, due date is D. Given the due date say D, we wish or we may wish to calculate how probable on the probabilistic sense, on a non-deterministic sense, is it that the project will be completed within that due date, which is what we need to find out is this. This is very important. So, what we need to find out is PR, PR is probability which is P here, it does not matter. So, we want to find out x is the random variable which denotes the overall distribution of the time for the overall projects for which the expected value is known to you, which is t, as mentioned in the normal distribution as shown in the normal distribution, and the standard deviations was SD in the bracket t. So, my main concern is this, I want to find out what is the probability alpha, because if alpha is very high, it means that I am able to finish on an average the job before the due date on a very high probability note, which would mean two things, that I do not incur extra cost, very simply mentioned here, because I am considering cost can come due to more overtime given if the job duration increases more than the due date, because I want to assign more and more people in order to finish it, or I want to assign more work to the same set of people giving them overtime. It may also mean that I have to resources extra some machinery, extra some land, consider land I utilize. It can be trying to utilize some extra help from other organizations, from vendors. So, these are very simple points which I mentioned. The other important fact which may be negative is that if I am the vendor and I need to supply and deliver to the government of India a road, considering the road connects the city of Bhopal and Indore. Now, if I am able to finish that work within the due date of consider 3 months, then obviously I do not pay any penalty. But if I deliver the overall project after the due date, then obviously as per the clause, as per the contract, I may have to pay some penalty. So, you may be asking that if that is the case, if I am able to deliver the job before that due date, obviously I should get some benefit also. So, those can also be brought into the picture considering the overall contract, how it is signed. So, if I consider x as the overall random variable depicting in the time, and if I consider central limit to be true, then x would have a random variable distribution as normal with an expected value of t and the standard deviation as S d bracket t or variance as calculated. So, variance calculated was basically sum of the variance for all the paths which are on the critical path. So, using simple standard normal concept. So, this is the formula which I have, which is x minus the expected value divided by the standard deviation is less than equal to d, which is the due date, minus t, which is again the expected value of t divided by standard deviation. Thus, considering t as 50 and standard deviation as 10 and d as 50, we would have basically that now this is considering that the Z is the standard normal. So, how it came about is exactly this, probability of 50 of less than equal to 50. So, this 50 is this one is equal to, I want to find it out. So, what I need is probability x minus its expected value divided by the standard deviation less than equal to 50 minus the expected value divided by standard deviation. This expected value E x is equal to t. So, I am using in general notion. So, this 50 and expected value is also 50. So, this 50 becomes 0. So, whatever it is, this is now becomes a standard normal deviate z. So, hence it is written as probability of z is less than 0. So, if you consider the normal distribution, the overall area for sum of all the probabilities for any distribution, considering from the minimum value to the maximum value, we know it is 1, and normal distribution being the symmetric distribution of above and below its mean, median and mode. So, this value z is equal to 0, which is the mean of the standard normal deviate is 0, standard deviations for this is 1. So, the overall coverage till the mean value is 50, that is why it is written as 50. So, this is 0.5. So, it is 50%. So, the chance the project will be completed within the due date of 50 is 50%. In other words, we can also state that out of these 100 such simulations we need to do before you basically commit your resources, and you want to find out where the overruns could have happened or where they can happen. So, out of the 100 such cases, 100 can be 200, can be 1000, can be 1,000,000. So, I am just giving an example. 100 cases of the same project being taken up time and again with the same time, which is expected value of x, which is 50, standard deviation which is given as 10, and due date d, which is given as 50. We will have 50 cases where the jobs will be finished within the due date, and 50 per chance of 50 such cases the job would not be done by the due date. We can also find the chance in probability that the job would be completed within certain due dates, which are given by two values d1 and d2. Consider like this: you are the vendor, and again coming back to the laying of the road from the city of Bhopal to Indore, and the overall average time decided due date is 3 months, and within that 3 months it is, if it exceeds the 3 months, but less than say for example 4 months, you pay a penalty of, consider, 2 lakhs per day. Now, after the 4th month your penalty increases to 5 lakhs per day. So, what you want to find out is that what is the probability that I would finish, I as the vendor would finish the job within that time frame of 3 to 4. That means, I am not able to deliver that job within the 3 months, but I am able to deliver it within 4 months. So, I know on an average what is the cost, which is 2 lakhs per day. I want to find out that what is the probability of paying that amount, because in case if I exceed the 4 month, the overall cost structure, the penalty structure, cost structure in the negative sense for me would now become not 2 lakhs, but 5 lakhs per day. So, in that case I need to find out that what is the probability that I exceed finishing the job for a time period more than 4 months, and what are the consequences I have to face. So, based on such practical examples, let us just give the concept very briefly. So, we can also find the chance in probability that the job would be completed within the due dates given by two values d1 and d2 as just mentioned. So, I need to find out that what is the probability. So, technically it is like this. So, my job would be completed within some d1 and d2, these due dates are given, I need to find it out. So, again going through the same simple concept of central limit theorem and the concept of standard normal. So, what I do is this, I will now just write down the formulas which would absolutely make very simple sense to all the students who are well versed in the concept of probability. So, it will be basically d1 minus t, which is the expected value by the standard deviation, less than equal to x minus t by standard deviation, which is less than equal to d2 minus t by standard deviation. Now, these value d1 is known, t is known, standard deviation is known. So, what I have is one small z1, which is the standard normal deviate value, realized value which I know, and I can check in the standard normal table. Here also d2 is known, t is known, and standard deviation is known. From there I find out z2. So, this value which is x minus t by standard deviation is basically the standard normal deviate z. So, I basically check, given d1 and d2 and t and standard deviation, I check the small z1 values, small z2 values, find out what is the overall probability such that I will be able to finish that job within that stipulated time of d1 and d2. So, if I go back to the graph, this is becoming a little bit cluttered, but please bear with me. So, what I actually have is this graph, this t, and these are d1 and d2. So, based on that I have this formula which I have given here. So, if I highlight, what I need to find out is that what is the probability inside the region as shown. between D1 and D2. Based on that, I can find out that what is the probability that I am able to deliver, because based on that I will basically recalculate my overall budget and take a decision whether I can delay or whether it is best to finish off that job before the D2 period using some extra man, material, giving overtime, trying to take help of other vendors, trying to pay them extra amount of money, such that I am able to overcome the overall loss which I may face if I do not utilize these extra resources of man, material and other things, such that in that case the overall time taken to finish the overall project now is more than D2, because if it is more than D2, what happens is that it will go into this region, where if I mentioned in the example that trying to finish up the road connecting two different cities in India, the overall cost is now 5 lakhs per day. So, if it is exceeds 4 months, which is D2, then the overall cost I have to bear is very high, with respect to the fact that if I am able to deliver before that time period of 4 months, then my overall cost to be paid by me per day is 2 lakhs, such that I am able to offset that utilizing extra amount of man materials, such that my overall cost budgeting remains under control. So, I am sorry for cluttering this 289 slide, but I am sure you would have understood the two important concepts. One is what is the probability of finishing within that deadline or D, and what is the probability of trying to finish up certain percentage of the job between two deadlines D1 D2, such that I am able to recalculate my overall cost structure for the project. So, the penalty structure for the project can be, say for example, as follows, that if you finish less than 6. So, coming back to the exact example which I finished in the 289 slide between D1 and D2, the deadlines and the due dates. So, if you are able to finish only 60% completion of the jobs, you pay a penalty of 15 lakhs. So, exactly there is a fixed penalty. In that case, what I mentioned, it was 2 lakhs per day. Between 61 and 69 percentage is complete, you pay a penalty of 6 lakhs. Between 70 to 79, you pay a penalty of 4 lakhs. If between 80 to 89 is complete, you pay a penalty of 2 lakhs, and between 90 to 99% complete, you pay a penalty of 1 lakh, which means more complete, less the penalty. So, we could also have added, if you see this slide, a 6th, 7th point accordingly, that if you are able to finish it before the deadline, obviously you do not incur a loss or do not basically pay a penalty, but it would be a negative of a penalty, in the sense you gain some from the actual customer to whom you are supplying that project, or to the government of India, consider you have signed a contract, that you get some benefit. So, the chance of the completing the project, whatever it is there, now this is percentage completions are given on a penalty on a linear scale or a step 5 function, which means that if percentage completed is, say for example, between 91 to 99%, the cost is, I am not giving the values which are written, I am just giving the some arbit variables. So, this is x. So, you would basically pay an amount of x. If it is less than 91 and say for example greater than 85, so these quantums which are taking percentage complete are just arbitrarily, they can be equally dispersed or not, depending on how we have framed the problem or what information which you have. This would be higher, say for example it is 2x, and in this case if it is less than 85% complete, it can be, say for example 4x. So, this x, 2x, 4x are again arbitrarily. So, what is important to note is that in this region between 85 to 91, or in this region from 91 to 99, the cost overshooting remains fixed. That means, if you are able to finish that particular percentage of work, either it is 91.5% complete or 98.9% complete, you basically pay a fixed amount. But it may so happen that this fixed amount may not be true in some of the contracts, where they would try to basically find out that what is the overall percentage you have finished and based on the percentage change it may be a nonlinear function. It can also be a fact that depending on the percentage they may also be like, they means the customer to whom you are supplying the project, they would also like to know that what is the number of days which are left to finish the project. Based on that the cost structure for the penalty may be calculated, or it may so happen that percentage wise is important, but they may like to look into the fact that what are the critical jobs which are finished. So, if the critical jobs are finished, then they are rest assured that the job would definitely be completed within a certain deadline, new deadline of D3, D4, whatever it is. So, if those critical jobs are finished, then your total penalty structure which you as the vendor are going to face would be much less in case if those critical jobs in that critical path are not finished. So, there can be different scenarios by way of which the overall cost structures can be calculated, based on which the overall cost for the projects can be calculated. A penalty structure need not be a stepwise function, as I just mentioned. So, as shown in the previous slide, so it was step function. So, within 91 to 99 some cost, within 85 to 891 some cost, and based on that you calculate. But in case if you have a cost structure which is non-linear, so what would be important is on two accounts. Number one, whether we are able to replace this non-linear cost structure by a step function. So, closer your step function is to say, for example, so what will be required is that whether these lines are able to replicate this horizontal lines are able to replicate your overall cost structure which is non-linear in nature. So, if you are able to do that, then trying to find out the calculations for the small quantum increase or decrease of the overall percentage finish of the job or the due date being exceeded can be calculated in much better way. That is one. Another can be, say for example, if I know the marginal rates of increase in the cost structure for the whole projects, if that is known to me, that means either it is increasing at increasing rate, increasing at decreasing rate, or increasing at a fixed rate. Fixed rate is basically the concept which we generally try to utilize in order to make our life simple and try to find out good results for the overall projects which are very complicated in nature. So, in case if the marginal costs are increasing at an increasing rate and increasing at a decreasing rate, then trying to find out the dy dx of the cost structure needs to be brought into the picture such that we are able to calculate the overall cost structure which is there for the project or for each and every activity based on which he can proceed. Another important fact is that if you remember in 2 or 3 slides before, I did consider one critical path and one set of non-critical paths, but showed that if the variances of the non-critical paths or the set of activities which are there on not critical paths is very high, then it may so happen that trying to exceed the overall due date may have an effect such that the non-critical path activities or the set of paths which are there not in the critical path may come into the picture such that we need to calculate that overall extra cost for those non-critical paths also, and also see whether the non-critical paths does really affect the overall critical path and the cost. If it does, then your cost would be twofold. Number one, coming from the fact that the non-critical paths are being affected due to overrun delays, due to say for example, high cost of some labor or high cost for some input material and such things, plus the fact that if it affects the critical path, then two things would happen. Number one, if I need to utilize resources, then the cost would increase as it would be for those non-critical paths, plus the effect is that if the critical path is exceeding, in the sense the time delay is happening, then as per the contract, what are the actual costs which have to be borne by the vendor, which is you, would also be considered in the picture. And then the critical index may change, because if the variations are happening in such a way due to external factors are happening in such way that it may affect the overall working of the projects based on which you want to do your scheduling for the set of activities which are there in front of you. So, now I will just consider very simply the concept of the project's life cycle and how it affects the overall planning of the project, and cost would basically come into the picture as a sub part of the overall project life cycle and how it is considered. So, if I consider the concept of time along the x axis and the concept of cumulative cost or the cost along the y axis, generally the project overall development and how it happens is like this, as shown in the 293rd slide. In the initial state, you basically conceptualize, try to find out what is the effect of the project and how it should be taken into consideration. Then you go into the planning stage, and obviously as you proceed from the concept, which is the leftmost bar or the vertical line which you have, then you go to the planning stage. Then slowly the overall cumulative cost increases. Now, cost increase may not be linear in shape, it has to be basically non-linear in shape. And then we go into the execution phase. There would be fixed cost, there would be sunk cost, there would be variable cost, there would be marketing cost, there would be cost related to man, to labor, to design, to intellectual property rights, and all these things have to be taken into consideration. So, as the execution phase ends and then the overall work for the project starts, considering it is an ongoing project, then obviously it will taper down, and taper down in sense the increase would basically become stagnant and they would be a straight line, almost a straight line. That means the costs are on a fixed scale, and if the project ends then and there, then obviously the project has to be wound up, and then the cost structure of the overall project would basically start decreasing. So, here if you see by hand, so the after the termination phase, the actual cost of the project should basically start decreasing and should technically be 0. So, if I consider the cost structure considering the introduction, the growth, the maturity and the stagnation and the decline of the project, then again you will see the overall characteristics of the curve is exactly similar what you saw in the 293rd slide. So, here the cost structure on the left hand side or the y axis is the cost, there it was the cumulative cost. So, they are generally almost the same. So, it is total cost, cumulative cost, whatever it is. So, here also it starts slowly and then exponentially rises, then at stagnation and the decline phase it starts decreasing. So, the project life cycle basically consists of, I will come to the project life cycle in detail with one or two simple ideas and readings to be done. So, project life cycle basically comes through the conceptualization of the project, the planning which needs to be done, the execution part and the termination of the project. So, basically if you have a big project which is one time, like building a bridge, building a factory, or trying to basically rig the oil and in either in Gujarat basin or in North Sea or in say for example in Assam, or you want to build a tank consider for the Indian army, or you want to basically start off a school. It can be one as a standalone project or it can be a continuous project. So, they can be execution phase, how you execute it, and then once the work is done, considering the overall the benefit of the project from the project point of view, from the organization point of view, from the social point of view, you will basically terminate the project and see how the overall cost structure, the benefit of the project has accrued to the society as such. So, with this I will end the 24th lecture and continue the discussion using the project life cycle and how the concepts are used in the 25th and the 26th lecture onwards, and then later on come to the concepts of GERT, QGERT and other things, and in between, as if you remember I did mention, I will do few problems in the area of trying to utilize the financial concepts in trying to basically rank a project or try to find out what are the returns for the project based on which you can take the decision. Have a nice day. Thank you very much.